So let's talk about what it does it mean to be a parallel line versus an intersecting line versus a skew line. Okay, now parallel lines are lines that never intersect. Oops, that's too fat. But there's something special about parallel lines. Yes, they don't intersect, but they are also in the same plane. Okay, so if I have some plane, my lines that don't intersect will be lying in the same plane. Intersecting lines are lines that meet or cross. Oh, another thing about parallel lines, they have the same slope. Okay. So intersecting lines just meet. Now skew lines are somewhat interesting. Skew lines are lines that never intersect, but they're not in the same plane. And that's the difference between a parallel line and a skew line. Parallel lines don't intersect, but they're in the same plane and they run along each other sort of like railroad tracks forever and ever and ever. Skew lines, and unfortunately this won't show up on the video, but okay, so parallel lines, skew lines. They don't intersect, but they don't run along the same direction. They're not running along the same path. So I can have this pin over here and I have this one over here, and if they went on forever, they would never intersect, but they're not parallel. Does that make sense? Yeah. Because they're going in different directions. They're not running alongside of each other. So skew lines don't intersect, but they're not in the same plane. So if I have a plane that's going this way and another plane over here that's going this way, these lines aren't going to intersect, but they're not running parallel. And a transversal is a line that intersects two lines. So if I just have, two lines running along, minding their own business, they might be parallel, they might not be, it doesn't really matter. You get some other line that comes along and runs into both of them, that's a transversal. Lines and transversals, but every side of a box represents a plane. So a box has 6 sides, so it has 6 planes. So the top plane, the side, this side, the bottom, the front, and the back are all planes. Does that make sense? So if you imagined that they continued on forever, they would be planes. Parallel lines are going to run in the same plane. So if we look at this line right here, AB. AB is in the plane that is this side of the box, and it is in the plane that is the top of the box. Does everybody see that? So parallel lines are going to be in the same plane. So if we just look at the line AB is parallel to EF, and AB will also be parallel to DC.
Do you want us to write this down?
Yeah, if you can. Or if you don't,
Can you draw it with the highlighter?
Not that. So what else is DC parallel to?
H.
Yeah. Okay, so we took care of those 2 planes. And then if we look at HG, we know it's parallel to DC, but what else is it parallel to? So we've kind of gone around all the 4 corners of the sides of the box, right?
Are D and C parallel to E and F, even though they're not on the same plane?
Actually, they would be if we had another plane that kind of like came diagonal, if there was a diagonal plane. They would be, but right now we're not representing that plane, so we're not gonna count it. But if I drew in a diagonal plane, like if the box had an X, cardboard X inside of it, you know, have you seen that for like packing?
Yeah.
Then they would be parallel because they'd be in the same plane.
What's it called if they're parallel but they're not in the same plane?
Skew.
Skew, yeah.
But we're gonna ignore those diagonals right now for both parallel and skew. Does that make sense? We're just gonna talk about just the edges.
But skew can only be possible on like three-dimensional figures, right?
Yes.
Like it can't be on a.
No, we can, because a plane is two-dimensional, right? And so skew won't occur in a two-dimensional because they'd be on the same plane. Skew only occurs when you're talking about three dimensions, so you have two different planes. Yeah. So, actually, you know what, we'll go ahead and count the diagonals. We're going to say that DC, if we had a diagonal plane going through the box, DC would also be parallel to EF, and that would make AB parallel to what else? Okay. Now, that's all the side corners, but we have also these front and back corners, right? The edges, sorry, not corners, they're edges. These are corners, those are edges. Okay. If we look at AD, what's AD parallel to? Yeah, EH and BC. They're both. Okay. So AD is parallel to BC and EH. And FG.
They're normally this many.
On a box, yes. Because there's so many sides. Okay. If you think about, let's go with BC. Oops. Oh, I meant to be highlighting.
Green.
I did BC green. So BC. What's parallel to BC? Yeah, FG. And we already did BC to AD. So EH, yeah. But yes, you're right. We just already had it. Yeah. Okay. I don't know, purple, I guess.
Would this be like a test question? You have to put all of these.
FG, what's parallel to FG? We've already got AD. Do we have EH? Nope, we don't. Okay, so FG is parallel to EH. Anything else? Well, BC, but we've already got it, right? Yeah, we did that one. Okay, so we've got all of those. So if I do EH, EH is parallel to AD, got that. EH is parallel to BC, got, yeah, that should be EH, not EF. Sorry. Got that, and then EH is parallel to FG, we've got that. So now what we have left are these long edges here, or these edges here, the heights. So I have AE. AE is also parallel to BF, and AE is parallel to CG. Okay, so okay, so I did the AEs. If I do BF, I've already got BF is to AE, so I need DH and CG. Okay. If I do DH, I've already got BF, I've already got AE, so all that's left is CG. And then if I take CG, I've already got AE, BF, and DH, so I'm done. These are all of the possible pairs of parallels. This is every single one of them. All right, so skew lines. Skew lines are non-intersecting, but they're not parallel, so they're not on the same plane. So if I look at BC, all of these are parallel, right? The bottom of the back of the box and then the front of the box, the top and the bottom would be parallel. These are going to intersect. All of these will intersect, right? So what we have to do is we have to determine which lines, which lines don't intersect but aren't parallel.
DH.
Which one did you say, DH?
Yeah.
Oh, wrong highlighter. Wrong color. Okay, DH is one. What else?
AE.
AE is another. EF and HG. So there's kind of like a pattern there. Do you see it? Like when you have a side, an edge of a box, the opposite L, those are the skew lines.
It shows on the right. What's the symbol for skew? Is it one? Did I just put a comma or what?
Hold on. Okay, so guys, BC is skew. To AE, EF, DH, and HG. Okay? Because these would intersect, and these are all parallel. Okay? The reason I had no picture in my head is because there isn't one. Okay. So that was BC. If we look at AD, oh, it's here.
No, under the line where you were writing.
Oh, and yeah, just the and symbol. Okay, so AD is going to be parallel to BC, FG, and EH, and it's going to intersect those. So that means that these L's don't intersect and aren't parallel, right? So that would be BF, EF, HG, and CG.
So you guys,
We're going to just say some. Okay, if we look at DC. Okay, we have intersecting lines, right? This line intersects, 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 so it's not those. Okay, parallel, 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 so it can't be those. So that's what's left are BF, AE, EH, and FG. So intersecting, if I look at AD, AD intersects with DH, AE, AB, and DC. Now, intersecting lines are going to have one of these two letters in them because this is the points of the end of that side of the box, right? So I have a D and A and A and D. That's the point where they're intersecting is at A and D. So they'll have those points in there. Does that make sense? So if I had some sort of like FG over here, it doesn't have A or D in it, I know that that's not correct. Just another way to check yourself. We're going to make this sum again also. If I went to BC, I have CG, BF, AB, and DC. Okay, any questions on the concept? What we've got in here is angles in a transversal. Okay, so here's, if I saw this is line L and this is line M, I'm going to call this T because T is the transversal. T is intersecting the two lines. Okay, and it's important to know which one is the transversal. The transversal is the one that touches more than one line. Okay. Alternate exterior angles are angles on opposite sides on the outside of the lines. Oops, the lines is not one word. Intersected by the transversal. I'm just going to put T for transversal. Now I'm going to make the alternate exterior angles red. Okay. Sorry, no, red and blue. Okay. These two angles are alternate exterior angles. These two angles are alternate exterior angles, so they come in pairs. So the alternate exterior angles are the pair of angles that are on the outside of the two lines on the opposite sides. So the two blues are a pair of alternate exteriors, and the two reds are a pair of alternate exteriors.
Are they equal?
Not yet. Because these two lines aren't parallel, we have rules when they are parallel, but right now they're not. So we're just identifying. Okay. Alternate interior angles are angles on the opposite sides Okay, so I'm going to make these green and yellow. Can you see the yellow okay? Okay. So these are on the inside of the lines intersected by T, but they're on opposite sides of T. So they're on opposite sides of the transversal on the inside. So the two green ones make up a pair of alternate interior angles, and the two yellow ones make up a pair of alternate interior angles. Okay. Then we have what's called corresponding angles, and corresponding angles are angles in the same position relative to T. So I'm going to mark these with shapes. We're going to have a star, a square, a triangle, a circle. Okay, these are corresponding angles because they're in the same position. If you had like four square, they're in the same square. Does that make sense? These are corresponding. These are corresponding. And these are corresponding. So like I said, if this was a four square, the angle or the angles that are in the same position of the two four squares are called corresponding.
Wouldn't it be the angles that share the same value?
Okay, when you have just two non-parallel lines intersected by transversal, the only relationship these angles have to each other is that the positions. The positions. And like these three will, or these four will add up to 360, but they don't have anything in common with these four. So once these lines are parallel, then we'll have relationships between the sets, but right now we don't. Okay, same side interior. These are angles on the same side okay, so one yellow and one green together make up a same side interior pair. Okay, so yellow and green, these are same side interior. Yellow and green, these are same side interior. Okay, same side exterior are angles on the same side. Side, if I could spell. Okay, so in this case, one red and one blue make up a same side exterior pair. Okay, so just to recap, we have two pairs of alternate exterior. Red is a pair of alternate exterior, blue is a pair of alternate exterior. We have two pairs of alternate interior, green and yellow. We have four sets of corresponding angles. The stars, the squares, the triangles, and the circles. We have two pair of same side interior, 1, 2, and then two pair of same side exterior, 1, 2. And unfortunately, I don't have a plastic box. Okay, so 1 and 4. Now, we didn't specifically go back over this, but this is the definition from first semester. 1 and 4 are across from each other. That makes them vertical. Don't forget, just because we're not still going over it doesn't mean we don't still use it. Everything is cumulative. So angles that are across from each other are vertical angles.
So they're equal?
Yeah, 1 and 4 would be equal. 2 and 7. We're outside and we're on opposite sides, so we're alternate
So why don't you just do 2 and 3?
exterior. Because I'm just identifying angle pairs right now, like what type of pair they are. 2 and 3 would also be vertical though.
Okay, alternate interior.
6 and 3, alternate interior.
Okay. 3 and 5 would be
Same side.
the shape. No.
Same side. See how they're on the same side?
Yeah.
Yeah, so they're same side interior.
Oh, okay. I was thinking 2 more.
Okay, 4 and 8 is what you were thinking, because they're, see how they're in the same spot?
Yeah.
So those are corresponding.
Corresponds.
Okay, so that's so angle 4 and angle 6 would also be same side interior. Vertical angles. We have 1 and 4, 2 and 3. Oops, angle 8, 5 and 8, and 6 and 7. Those are all the vertical pairs. Okay, alternate exterior. We have 2 and 7. What's the other pair of alternate exterior?
1 and 8.
Yeah. Alternate interior, I've got 6 and 3. What's the other pair?
4 and 5.
Same side interior, I've got 4 and 6. The other pair is
3 and 5.
okay. Corresponding.
3 and 7.
Okay.
So would 1 and 5 also be?
Yes, angle 1 and angle 5.
2 and 6.
Yes, angle 2 and 6, and there's 1 left.
4 and 8.
Well, we got 4 and 8.
Oh.
Wait, 3 and 7.
That's it. 2 6. 2 6. You got 1 5. You're good.
Oh yeah, okay, that's it. Is we have, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Okay, so if I have two lines, oops, those are not parallel. L and M, and L is parallel to M, and they're cut by some transversal. corresponding angles are congruent. And I'm going to use color again, sorry. So those two angles will be the same. These two angles will be the same. These two angles will be the same. And these angles will be the same. Okay, but line L and M have to be parallel for that to be true. Okay. We have three theorems. Basically, all of them are saying that L is parallel to M. If L is parallel to M, alternate interior angles are congruent, alternate exterior angles are congruent, and same side. Yeah, typo. Sorry, supplemental. So same side interior angles add up to 180.
Seems a pattern here.
Okay. Sorry, I got typing congruent, 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 but it wasn't meant to be congruent, congruent, congruent. It was meant to be congruent, congruent, supplemental. So excuse my typo. Okay. Okay, L is parallel to M, right? They have to be parallel. If they're not parallel, it doesn't work. So this is a requirement. The green, those are equal. Yeah, the green are equal. Hold on, I need to put another green down here so I don't have to switch back and forth. The purple are all equal, and a green plus a purple equals 180 degrees. So, when you have these 8 angles, okay, it's kind of like a checkerboard. Like if there was like closer and there was a line. Do you see the checkerboard? So you know every other color? Get it? Checkerboard? All of the purple squares have the same angle measured. They're all equal. So if this is 50, this purple up here is 50, this one's 50, this one's 50, and that one's 50. Okay? Now purple plus a green equals 180, so if the purple's 50, the green is 130. So if this one's 130, this one's 130, this one's 130, and that one's 130. So if you know one angle, you can find all other 7.
Nice.
Yes, perfect. Okay, M is parallel to N, and I want to prove that angle 2 is the same as angle 3. What do I know about angle 1 and angle 2?
They're congruent.
Yes, because they're vertical, right? Okay, wait a minute. I have to go back. Theorem 18, I'm proving that the alternate interior angles are congruent. So I'm proving that 2 is congruent to 3. Well, I have 1 is congruent to 2. I have 1 is congruent to 3 because they're corresponding. So 2 is congruent to 3 because we are just going to substitute that right all in. Okay, if angle 1, that's this one, well, that's the same as these ones, right? And then I said these ones were the same. So if angle 1 is 100, what's angle 2?
80.
Okay, so then angle 3 is, 4 is, 5 is, 6 is, 7 is, 8 is. See? See how easy that was? So once I knew the 1, I subtracted 180 minus 100 to get the 80, and then all the rest are just 180. One. Got it?
Will it always equal 180?
Yes. The two different colors together always will equal 180 because see how they make a straight line? And straight lines are 180.
So how do you make it equal 90?
If you have a straight up and down, well, okay. That was in my way. If I had this and I had two parallel lines and this one was 90, then they would all be 90. Does that make sense? Okay. All right. Now, angle 1 is 115 degrees. And angle 4 is 3x minus 5. And what do I know about angle 1 and angle 4? Well, first let's do our checkerboard. Yeah, so angle 1 and angle 4 are congruent. So, actually I'm going to write it the other way. 3x minus 5 is equal to 115. So then I divide by 3, x is 40.